Okay, hi there, Calculus 3 students. Let's work on a few problems in your second homework assignment, okay? Here, let me make sure my volume is up. Okay. Maybe that's a little better. If it's too loud, my voice is going to sound really funny, and there's going to be a lot of static. So I really don't want the microphone to be too loud. Maybe just a little bit softer. Hopefully that'll be okay. I'm using a different computer than I usually use. This is a different laptop, so forgive me for fumbling around a little bit. Okay, I'm looking at question 128 in your second homework assignment. The question is, find the points, if they exist, at which the following plane and curve intersect. Y plus x is equal to 0. Okay, that's going to be the plane, and the curve is given by a vector valued function r of some parameter t, where the x component is 5 times cosine t, the y component is 5 times sine t, and the z component is t, on the interval where t cannot be less than 0 and t cannot be greater than 4 pi. Okay, so this is, a little bit of a challenging problem, but it's not too bad, and we can use Mathematica to help. Now, if you think about it, I'm going to put in a comment here. Y plus x is equal to 0 means the same as y is equal to negative x. Okay, so I think, we can all agree on that. And of course, that really means the same as negative y is equal to x. Okay, my puppy's walking away. Keeping one eye on the dog right now. Okay, so, and hopefully, everyone can understand that. That's just basic high school algebra. So y plus x is equal to 0 means the same as y is equal to negative x. Maybe I should put a space over here. Okay. And that really means the same as negative y is equal to x. Okay. So I'm just going to press Shift Enter. Okay. Now, in order to find the intersection, right, what I'm going to have to do is set x is equal to 5 times cosine t and set y is equal to 5 times sine t. So let me say that one more time. In order to find the points of intersection, I have to set 5 times cosine t is equal to x and 5 times sine t is equal to y. Okay? Now, I know from just high school trigonometry, let's take the sine of 3 pi over 4. And that's going to be 1 over the square root of 2. Let's take the cosine of 3 pi over 4. That should be the negative. That should be the opposite of sine 3 pi over 4. And it is. Okay, so the sine of 3 pi over 4 is some value, 1 over the square root of 2. And the cosine of 3 pi over 4 is the same value except the opposite. It's the negative. It's negative 1 over the square root of 2. Okay, so what we have to do is figure out all those values, all of those angles on the interval where t is between 0 and 4 pi. Okay, and that should be pretty easy to do. So let's figure it out. I'm going to use the table command. I'm going to use Mathematica's table command. Table, let's see. If 3 pi over 4 plus pi, when I say pi, that means half a rotation, times n is an integer, okay, if it's less than or equal to 4 pi, then simply give me 3 pi over 4 plus pi times n. N goes from 0 to, I don't know, we could go to 20. We could go to any, in a large integer. Okay, so I'm not getting, hold on one second, I'm getting something a little freaky here. Oh, because we don't know, here, I made a little typo, sorry about that. This should be pi, not p. That should, okay. Yeah, that should be, I wrote p, that should be pi, 4 times pi. Okay, that's much nicer. Okay, I was kind of wondering about that. Okay, what's going on there? Okay, so if 3 pi over 4 plus pi times n is less than or equal to 4 pi, okay, give me 3 pi over 4 plus pi times n. And we're going to experiment by using all, for n, all the integers from 0 to 20. We obviously have a lot of overkill. Right? Okay, so the 4 values would be 3 pi over 4, 7 pi over 4, 11 pi over 4, 15 pi over 4. And we can get rid of the nulls. Let's get rid of those nulls. Delete cases. Put a comma here. What should I call it? Number. I'll call it number, such that number is equal to null. Okay, so those are my values. 3 pi over 4, 7 pi over 4, 11 pi over 4, 15 pi over 4. Okay? And let's see, what should I call that? T values. Okay, Shift Enter. So now I can see that I really should have 4 answers. So R of t, well, t values 1, that gives me the first answer, and t values 2, that gives me the second answer, right? And t values 3, oops, that gives me the third answer, and t values 4, that gives me the fourth answer. But I have to plug these back into my R function, which I haven't defined yet. I have to define R. So R of t is equal to 5 times cosine t, 5 times sine t, and t. And there's a restriction here. The restriction is that 0 is less than or equal to t, and the double ampersand means and t is less than or equal to 4 pi. Okay. R of t values 1. Okay. R of t values 2, R of t values 3, R of t, whoops, Mathematica is case sensitive, R of t values 4. Okay, these are my 4 answers. Now, what you're going to have to remember is this. Mathematica, unfortunately, does not rationalize, it does not rationalize the denominators of fractions. So, for example, if the answer is 5 divided by the square root of 2, that's it. Mathematica will show you, 5 divided by the square root of 2. Pearson, on the other hand, wants you to rationalize your denominator, which means you have to multiply numerator and denominator by square root of 2. So, according to Pearson, this fraction right over here, for example, that fraction would be, negative 5 times the square root of 2 over 2. So you kind of have to maybe write it down on a piece of paper or just, commit that to memory. So the answers will be, okay, let me see here. Let me kind of stretch that window out a little bit. Is it B? A lot of numbers to look at here. I believe it's C. Let me check my numbers. Okay, so 5. Okay, negative 5 square root of 2 over 2, 5 square root of 2 over 2, 3 pi over 4. This is 5 square root of 2 over 2, negative 5 square root of 2 over 2, 7 pi over 4. Okay, hold on 1 second. Negative 5 square root of 2 over 2, 11 pi over 4, and this is 5. Yeah, so you know what? It's going to be C. Okay. And really, I don't think that was too hard, right? That was not terribly difficult. Yeah, I don't think that was so bad. Okay, so the important thing is this: when you're using a computer program to help you solve math problems, you're kind of learning 2 languages. You're learning the language of math, but you're also learning the language of the software, the language of the program. So let me go over a few things with you, because I think we need to be very clear about something. Like, for example, we need to be very clear about more than something. We need to be very clear about many things. Okay, for example, excuse me, what does delete cases do? There's a cases function, there's also a delete cases function, and they're very similar. They're basically opposites of each other. Okay, so for example, let's say I had a list like this. My numbers is equal to range 100. And it's going to give me all the integers from 1 to 100. But let's say I only want the even numbers. Just the evens. Okay. I could do this. Cases, my numbers, make up a variable name. We all love X, but you don't have to use X. You could use A. You could use ABC. You could use num. I don't care. Use whatever variable name you feel like using. Okay, we could use X. Okay. Even QX, which means is the number even. So now I have only the even numbers. Okay? Or I could do this. Delete cases, my numbers, odd QX. So now I'm deleting the odd integers, the odd numbers. I mean, it's the same thing. It's really the same thing, right? You're just approaching the problem from the opposite end, but it's the same idea. Okay? How do you test if a number is even? Even Q4, true. Odd Q4, no. 4 is not an even number, so I expect false. 4 is an even number, so even Q returns true, odd Q returns false. Okay, very simple, right? Okay, so this problem really, if you approach it the right way, it's really not that horrible. It should take you really just a few minutes. Okay. Let's see, excuse the sore throat. Find the length of the line, excuse me, I'm losing my voice this morning. Find the length of the line given by r of t is equal to, okay, the x component is 9t and the y component is 10t for t is between a and b. That's a little tricky, but maybe not too bad. Type an expression using a and b as the variables. Type an exact answer using radicals as needed. Well, we're going to remove, remove r, and let's redefine r. r of t is equal to, it's a vector valued function, the x component is 9t, the y component is 10t. Shift enter, okay, terrific. Now we have to remember, what is the definition of arc length? How do I find arc length? So we're going to have to use an integral. Okay? So escape, press the escape key. INT, T, escape again. Okay? My limits are from A to B. Yeah, I can let t be my variable of integration. I think that's okay. Actually, in this case, I don't think it's really going to matter too much. So the derivative, well, here, square root, control 2. The derivative of the x component is 9. Okay, the derivative of the x component is 9, and 9 squared is 81. Okay, and the derivative of the y component is 10. 10 squared is 100. So I have 81 plus 100. We could simplify that and just say 181. 181. Shift enter. Okay, so you know what? Let's make that look a little nicer. Expand traditional form. Okay, we could factor that out. So it's the square root of 181 times b minus a. The length of the line is the square root of 181 times b minus a. Okay, very simple, right? All I did, I just factored out the square root of 181 just to simplify the expression. I'm sure, I'm sure you could get Mathematica to do that for you. Yeah, well, it's reversing it. Instead of b minus a, it's giving you a minus b. It's the same thing. Okay. Let's do one more problem. Let's see. Let's do a problem that's just a teensy bit harder. Okay, so, all right, this is going to be the last problem for the video. I think I'm going to have to make another video. So here it says, find the length of the following two-dimensional curve. Okay, so let's give this a shot. Remove, or I could clear it. I don't think I have to totally remove it. Clear R. R of t, let's redefine R. is equal to t squared over 2, 2 times t plus 1 to the power of 3 over 2, and the whole thing divided by 3. Okay, that looks good. And the limits of integration will be 0 and 16. The limits of integration will be 0 and 16. So guys, it's the same thing as before. You take the derivative of the x component, you square it. You take the derivative of the y component, you square it. You place that under a square root, and then you integrate on the limits from 0 to 16. Now, what makes the integration kind of tricky is that you're dealing with a square root. So you guys remember from Calculus 2 that in order to solve a lot of those problems, where the integrand has a square root, you're going to have to refer to a table of integrals, or you're going to have to use a complicated trig substitution. That's just too much work. I mean, you can do that. Yeah, that's good to do. That's good to do a couple of times, 2 or 3 or 4 times for the sake of practice. But you don't, you really shouldn't have to do that every single time, because a lot of that turns into busy work. It really becomes busy work. And we have a lot of other stuff to do this semester. So let's use the software to make this go much faster, okay? So, by the way, that's going to give me the x component, right? This is going to give me the y component, or the second component. Just remember that. Press the escape key. D int. That's 2 t's. Escape again. Okay, your lower limit is going to be 0. Your upper limit is, sorry about that. Your upper limit is going to be 16. And the variable of integration is t. Control 2 gives me a square root symbol, or a radical symbol. Okay. The derivative of r of t, I want the x component with respect to t. Control 6 squared plus the derivative of the y component with respect to t squared. What does that evaluate to? Shift enter. That evaluates to 144. The length of the curve from 0 to 16 is 144. And that's correct. Okay, so just a heads up, so I don't want this video to get extremely unbearably long. I prefer to do short videos. Especially, there's a lot of stuff going on in the household, there's noise, I have a dog, so, and I'm sure any minute now he's going to start barking. So it's not really easy for me to make, it's not easy for me to make long video lectures. I know that's probably what some of you prefer, but I'm not really sure if that's a good idea. And besides, excuse me, personally, when I watch a YouTube video, maybe you guys are different, but when I watch a YouTube video, I'm usually interested for maybe the first 15 minutes, and then, I kind of become impatient and I start to lose interest, and then I look at something else on the internet. So I think if I make these videos extremely long, I think many of you are going to become bored, and you're not even going to watch the entire video. Because I think, most of us nowadays, we live in a very fast-paced world, and let's face it, most of us have a really poor attention span. We look at something for maybe 15 minutes, 10 minutes, 20 minutes, and then we get bored, and then we look at something else on the internet, or we look at something else on YouTube. So it doesn't make sense, in my opinion, for these videos to become super long, because, are you really going to watch the entire video? Some of you maybe, some of you might watch the entire video, but I have a feeling most of you won't. Okay, because people get bored quickly, they get distracted quickly. Okay? You have some problems at the end of this section. Hold on one moment, please. Excuse me. You have some problems. You have some problems at the end of this section that deal with something called arc length parametrization. This is another reason why I don't like to do long videos, because I'm susceptible to sore throats. So it doesn't make sense for me to do a really long video. Excuse me. You have problems later on in this homework assignment that deal with something called arc length parametrization. So basically what that means is I would need to create a new function. I could call it R prime, or Q or S. I think in this homework assignment they call it S. They create a new function called S. Okay, S of U. And let's say that I give the function the parameter of 144. The function would return 16. It would tell me, the function would tell me how far along the curve must I go in order to have a length of 144. So instead of 16 being an input to my function, the input to the function would be 144, and then the output would be 16, which tells me in order to have an arc length of 144, I would need to extend t to the value of 16. So it's kind of like the opposite of this problem. Okay, I don't think I'm going to put it in this video. Maybe the next video. Okay? So we do have a few of those problems, and they're not that bad, but they can get just a little bit tricky, because you have to do a substitution in order to make it work. Okay guys, I think that's going to be enough. And email me if you have questions or problems. And just very quickly, a heads up. Table. The table command in Mathematica is very easy. 3 times k, or 3 space means times, plus 1, k goes from 0 to 10. Okay, so 3 times 0 plus 1 is 1, 3 times 1 plus 1 is 4, 3 times 2 plus 1 is 7, 3 times 3 plus 1 is 10, 3 times 4 plus 1 is 13. Do you get the idea? I mean, it's pretty simple. It's pretty simple, okay? I think I think you might be able to use the range command to do the same thing. Range, let's see, 1 to 31 in steps of 3. Yeah, so range starting with 1, going up to 31, and in increments of 3. So it'll give you the same answer, although ultimately this is a much more versatile function. You can do more with table than you can with range. Okay, I think that's enough calculus and Mathematica for this morning, and I will look forward to hearing from you at some point in the near future. Get your quizzes done, and make sure that you look at your Pearson course shell to make sure that you're staying on top of all homework, quizzes, and tests. Okay, thanks for watching, and have a great day. Bye-bye.